you have the quiz. Now, as a reminder, this is not just on nomenclature. First off, once you learn it, don't forget it. And second off, oh, it's fair game. And third off, there is stuff in that bond unit that we never got to quiz on.
Huh?
Yeah, you learn stuff for the nomenclature. We never
I
quiz
know. I just don't know if we have a quiz.
Alexis Purdue report to 1032. Alexis Purdue to 1032.
You didn't come back. Yesterday I worked out. You had checked the
Maybe she went $6 last year. That's trouble. Big thumb, Mark. That's a little real dollars.
Yes, sir. All right. So, as you can see, the nomenclature 2 sheet, I went on and did it in first period, second period. So that answer key, literally the video is uploading right now. So whenever you go home, if you decide that you would love to go look at this and watch the video of how we get these, you absolutely can. I do want to stress some things out to you.
And you stress me out.
Good.
You're the reason she passed out this morning.
You passed out.
We told you this, Mr. Hall.
Yeah, I asked you maybe you should ask if I'm okay.
And I did ask if you're okay. Then you said that to me. You
I
said
was
yeah.
joking.
Alright, so on this, okay, some key things I stuck out is like here. If I gave you this name, oxygen, what's the chemical formula?
Oh.
2.
Yeah.
Because it's a diatomic that exists in nature bonded to itself. The 7 diatomics names are literally the element name, but the chemical formula is that element symbol 2. So O2, N2, F2, I2, all those diatomics. Then my personal favorite one. Right here. Chlorine dioxide.
How will that be a 2?
Dioxide.
Wait, that was a 2. Why did I say that?
So, chlorine dioxide is ClO2. I have a question for you. Yeah. What is that?
I have 5.
ClO2 minus. What is that?
Wouldn't it be chlorine 2 dioxide, like chlorine 2?
Nope.
Wait, why did you put that?
I put this here because in the video I wanted to stress something to make sure that you, once you learn it, you don't forget it, because all is fair game. It's a polyatomic. What's its name?
Chlorine oxide.
Chloride. What's the difference? This has a charge. This does not.
Wait, time out.
Boo.
You know the polyatomics,
Don't forget.
Yeah, but I was.
which is why I pulled this.
Can I have a periodic table? How many questions will there be on this?
I don't know. I haven't decided yet.
I just think you should just make it easy.
No, there are 7 diatomics.
Just
There's
make it
25
feel good
polyatomics.
about
Right?
Why were you in here?
Okay, so if it has a charge with it, it's chloride.
If it has a charge like that, it's a polyatomic.
Will you be mad if I come in tomorrow go overs and stuff. Cause I know how to do it.
I ain't be mad.
Like I got all of those right.
When y'all come in, you don't make me mad. Now, when y'all come in and you look at me and you say, teach me in 30 minutes what we've spent 2 weeks learning, I snicker, and in the back of my mind I'm thinking, ha, good luck.
Well, this is about what I remember.
Me too.
Put Jesus on it and give you one.
That ain't good for nobody.
Alright, so on this, I want to do the nomenclature practice sheet 1 with you guys, so that that is there for you all and there for second period, okay? So on this, here's the key with these. You have to know when to use what set of rules.
Can I have a period of time?
You have to know when to use the stock system, the non-metals and non-metals, and the chemical formula.
I wouldn't set it like that, but sure. Alright, so, ladies and gents, this will be good practice for y'all, see how y'all are doing, and get us a little bit of the way through this. Okay? So that you understand and are aware and that you know. We will kick up and start rolling with nomenclature again after this quiz. And we're going to get to the hard stuff. Okay?
Is it the hard stuff yet?
Not okay.
No. Alright, so in this, I give you the chemical formula and I'm asking you to name it. So in this case, we have KF. This is what you got to be able to realize. I'm not going to be pulling the periodic table in and off on this. I love y'all dearly. I should not have to tell you anymore that column 1 has +1 charge, column 2 has +2 charge, column 13 has +3, column 15 has -3, column 16 has -2, and column 17 has -1. I've said that so much, I'm about to tell my wife to make me a t-shirt and just hang it up in here.
That would be
That's a good
nice.
idea. T-shirt. Why don't you just do a sign?
I like t-shirts. In this, highs and lows of this, staircase separates the metals over on the left and non-metals over on the right. These are all things you need to be able to know about this. There's a reason I'm giving you these on your quizzes. You need it. Alright, so first thing we're going to look at is KF. So, where is K?
In the
Right-hand side.
Non-metal.
It's a non-metal.
It is a -3.
It's an S.
It's in the S block.
Third column.
Let's pull this back in. Potassium's right here, first column.
S.
So it means what charge is on potassium?
1.
+1. What charge is on fluoride?
3.
-1.
-1. Okay, I just did that to check, see if y'all can get the charges. You don't need the charges in order to name this, because this is potassium, a metal or a non-metal.
It's a metal.
Potassium's
a metal.
Potassium's a non-metal.
Non-metals are in the over on the staircase, aren't they?
No, that's not.
Staircase.
Yeah. Non-metal.
To the left.
Metal. Metal.
That's a
Metals. That looks really weird. It looks like.
towel.
If you need any more help in knowing if this is metals, my first L lined up with the A for some reason. What is another name for the D block? The transition
D block.
metals.
D block dudes. Chemical stock formula. Stock system.
Stop.
Please stop guessing.
We're not.
That's what it says. It's the stock system.
The D block.
They got foods.
God.
D block.
We're trying.
How about we
D block are called transition metals, like I just said.
You never said that.
I literally just
We
said that.
probably weren't here when you said that.
I just said it!
Our heads weren't here.
I was close. I just wasn't sure about the thing.
Please don't scream. I've already got it.
I do too. On the right,
Non-metals.
non-metals. I should not have to say this anymore. Left of staircase, metals. Right of staircase, non-metals. So what is fluorine?
A non-metal.
A non-metal. So a metal and a non-metal gives you a what? What type of bond?
Ion.
So ionic bond. So then from there you have to determine your cation. From the cation, is it in the D block or does it carry a fixed charge? My question to you, which one of those two is the cation? Potassium. Thank you. Potassium is cation. It's in the first column, which means it has a fixed charge, which means we name it based off the monatomic cation and anion. So let's name the cation first, which is just the element name, so potassium. And then we name the anion. Whenever we name the anion, we take the element name, remove the ending, add IDE. IDE, so fluoride. Potassium fluoride.
But if F had a 2 beside it, would we just put fluorine?
The only way you would put fluorine is if it was fluor, like by itself.
Mr. Hall, can I ask a question?
Yes.
I don't know if there's one like this, but is there any way we would have like 2 in the S block? Like,
No.
so, okay.
This F2 is fluorine. Why? Because it's a diatomic.
It's bonded to itself.
27 diatomics naturally existing in nature.
Zero towards the office.
Alright, so in this number 2, we have Cu, which is copper, and O, which is oxide, which comes from oxygen. In this case, where is copper? In the D block, so it's a metal, so we have a metal and a non-metal, which gives us an ionic bond. So determining from your cation, which one's cation? Copper. So copper is cation. We have it in the D block, which means it carries multiple different charges. So we have to use the stock system to name it. Whenever you're using the stock system, you write the element's name down. Copper.
2.
In parentheses, we're going to put a Roman numeral to show the charge. How do we find the charge? It's all based off of the overall charge of the anion. Oxide, what's the charge of oxygen? -2 comes from the 16th column. How many of those oxygens do we have? So -2 times 1 is -2. That's the overall charge of the anion. So, it has got to have, the overall charge of the cations have to be equal to that. So it must be a plus 2. Divide the overall charge by however many cations you have. How many coppers are there? 1 gives us a plus 2. So, copper 2. Oxide.
Every time I write oxide, I make my O. And I don't know why.
Alright, on your sheet there was an error here, but I'll fix it on mine. You had Mg2F, but there should not be a 2 next to the Mg. On this one, Mg, metal or non-metal?
No, metal.
Metal. F, metal or non-metal?
Non-metal.
So we have a metal bond with a non-metal. What type of bond? Ionic. So we have to use the ionic naming rules. Look at the cation. Does the cation carry a fixed charge? Yes. What is the charge
2.
of cation? Plus 2. Nice job. Let's just check and see if you know your charges. So it has a fixed charge, so we name it off the monatomic ions. So first one, magnesium. Anion is fluoride. Any questions? All right, go to number 4. Number 4, we have sulfur and oxygen. Sulfur, metal or non-metal?
Non-metal.
Non-metal, oxygen, metal or non-metal?
Non-metal.
So a non-metal and a non-metal gives us what type of bond?
Covalent.
Covalent. So what set of naming rules do we use?
Prefixes.
The prefixes.
Not our friends.
So in the first case, you write the element's name down, sulfur. Do we have to give sulfur, in this case, in number 4, do we have to give sulfur a prefix?
No.
Why? Because there's only one of them, so we do not put mon, okay? Go to the second one. You always start with the prefix. No matter what, it will always be there. So oxide. Number 5, NO2, nitrogen. Metal or non-metal? Non-metal. Then go to oxygen, metal or non-metal?
Non-metal.
So non-metal, non-metal, what naming rules?
Prefixes.
Prefixes because it's covalent bond.
Almost said covalent.
Oh, sorry.
That's fine. I wouldn't yell. So, element name? Nitrogen. There's no reason to put a prefix with nitrogen because there's only one. Di, because of the 2 for the oxygen. Oxide, because it's oxygen. So nitrogen dioxide. All right, go to number 6. PbS2. Pb is lead, metal or non-metal? Metal. S, sulfur, metal or non-metal? Non-metal, what type of bond? Ionic, so look at the cation. Does the cation, is it a transition metal or does it follow the D-block dude rules? The D-block dude rules. Therefore, it can carry multiple different charges, so we have to find its charge. I'm going to start with writing the name of the element, lead. Start with my parentheses because I'm going to put a Roman numeral in there to show the charge. Now we got to find the charge. How are we going to do it? Look at the anion, look at sulfur. What's the charge on sulfur?
-2.
-2. How many sulfurs we got?
2.
2. So -2 times 2 is -4. That's the overall charge of the anion. The overall charge of the cation has to be equal but opposite. So +4 divided by how many of the cations you have. So 1, which is +4. So Roman numeral 4, sulfide. This is a great time for me to stress the importance. On your quiz tomorrow, don't miss points because you don't know the Roman numerals. If it goes above 3 and you're not sure, ask me. Okay?
I haven't seen one though that goes above 4.
They do.
There is.
Well, it be on our test though, cause like on this, I don't have.
Can
one
you
that
just
like-
write down the Roman numerals on the board before we start? Like our quiz. Before we quiz.
Why didn't you
Sure.
put
I'll do it. Remind me.
Thanks, Mr. Hall.
Welcome. See, I got a nice heart. Whenever I was leaving this morning, I told Mary, I said, I'm going to have to decide how mean and cruel I want to be on this next quiz. And
Please
she
don't
said,
be mean. We had a rough quiz last time.
she told me that I had a heart, that I wouldn't be too mean or cruel.
I love her. You married the good woman.
I did. I married a great woman. Funny thing is I got people from second period that started messaging her, asking her, please, tell your husband have mercy.
Mr. Hall.
Yeah, please have mercy on us. We got rough last time.
Bye.
Please,
mean
it's
to
five,
sing.
right?
Yeah, we mean just second period. We've had
Their
a
turn.
Now that it's been explained to me again, I do it.
I think I got like 40 outfits, 30 or 40 outfits. Yeah, I don't remember, but it's probably better than
It's not
All right, number 7. We have nitrogen and bromine. Nitrogen is, I feel like you guys are picking up on it, so I'm just going to roll through. I feel like you're getting bored with it. So it's nitrogen's non-metal, bromine's non-metal, therefore covalent. So we have to use the prefixes. So nitrogen and no prefix simply because there's a 1 with the nitrogen. Br3, tri for the 3, bromide.
And none of these have to be capitalized, right?
Nah, I ain't gonna hold against you if you capitalize it or not.
Okay.
If it was like gonna be labeled on something, then I would capitalize it. Now, if you're going the other way, like if you did like on practice sheet 2, yeah, these have to be capital.
Okay.
Because those are chemical symbols, so like here, antimony tribromide, that SB, the S has to be capital and the B has to be lowercase. Why? Because the first capital in the chemical symbol first letter must be capital. Second one must be lowercase. Same thing with bromide. Capital B, lowercase r. Alright, so N2S, nitrogen is a nonmetal, sulfur is a nonmetal, so covalent bonds. Name it based off of the covalent bonding rules, which use prefixes. So 2 is di, nitrogen,
Sulfuride.
monosulfide. The second one always gets the prefix. Dinitrogen monosulfide. It's a mouthful. Number 9, SR is strontium, comes from the second column, therefore metal. P is phosphorus, it's a non-metal, so ionic. Strontium has a fixed charge, so name it based off of the cations and anions. So it's strontium. Spelling it. No, I'm good. Strontium phosphide.
It wouldn't have a prefix on it?
Because strontium is a metal.
Oh,
Phosphorus is a non-metal.
okay.
Ionic bond. Alright, number 10. pH3. Hydrogen is one of those little tricks in there. Hydrogen is a non-metal, even though it's over on the left. So phosphorus is non-metal, hydrogen is a non-metal. So it's phosphorus. Tri for 3, hydride.
That's the trickiest word.
Good.
Trihydride.
Yes. Number 11, SN is 10. 10 is a metal. F, fluorine, is a non-metal, so ionic bond. Based off of that, 10 will follow in with the D-block dude's set of rules, so we have to show a Roman numeral, have to get the charge. Charge on the fluorine. On the fluoride is -1, there's 2 of them, gives me a -2, means the overall charge of the cations must be a +2. Divide that by however many there is, there's only 1, so that gives me +2. So 10, 2, fluoride. First question, stop me. Number 12. B is boron. F is fluorine. They're both non-metals, so non-metal naming rules. There's only one, so boron. Try for the fluoride. And fluoride. For 13, P2Br4. Phosphorus and bromine are both nonmetals, so covalent bond, use prefixes. Diphosphorus, tetra, bromide. Good job. (14) has copper and sulfide. Copper is D block, so it's a D block dude. Has got to have Roman numeral with it, so first step, name the first element. Copper. Parentheses, got to find the charge of copper. Charge on sulfur, -2 times 1, -2. So copper must be +2. There's only one of them, so it's +2. Copper 2, sulfide. Yeah. All right, number 15. 15. We have iron and oxygen. It's a metal, non-metal, and iron's a D block. So D block good rules. So iron, gotta find the charge. Oxygen has -2 charge. There's 3 of them, so it gives me a -6. So I gotta have a +6 for the overall for the cation. There's 2 irons, which gives me a +3. So it's iron 3 oxide. BeCl2. Be is beryllium. Beryllium and chlorine. That's metal and non-metal. Beryllium has a fixed charge, so name it based off of monatomics. I don't want to spell this.
Are you gonna hold spelling and stuff?
I mean, if you're close, it's okay. Like if you put an extra R in beryllium.
We shouldn't spell it wrong. We have a.
I know you have it, but.
I can't spell that.
Or like a perfect example is phosphorus. If you misspell it, it's okay. Fluoride, I know some people forget the U. If you don't throw that in there, it's okay. I'm not going to kill you.
We will get a periodic table that right?
Yeah, you'll have periodic table. Beryllium chloride. Number 17, K2S. Potassium is metal. Sulfur is a non-metal. Ionic. Potassium has a fixed charge, therefore named off monatomics. So potassium. Sulfide. Number 18, you guys have all heard about this one. It's CO. It's carbon and oxygen, so they're non-metals. Covalence, which means use prefixes. So there's only one carbon, so we just name the element carbon. Then O, we have one, so mon oxide. Carbon monoxide. Number 19, MgO. These are one of those that you guys will get to see before the end of the year. We will make some of this. MgO is magnesium, which is a metal, and oxygen, which is a non-metal. And magnesium carries a fixed charge, so name it off of monatomics. This is magnesium oxide.
Isn't that something you see on commercials? It's like extra MgO or something like that.
That's something else. That's I can't remember what it stands for. In that case, they're not saying magnesium oxide. It's like some preservative. All right,
Yes.
back page. We're rolling good. All right, so in this, Number 20. RB3. N. RB is rubidium. N is nitrogen. Ionic bond. Rubidium has a fixed charge, therefore we're naming off the monatomics. So rubidium. See, like I gotta look at the names. Rubidium nitride. '21 is SiO2, silicon and oxygen. They are both nonmetals. Therefore, covalent bond. So we will use the prefixes. So silicon, di for the 2, oxide. '22 RBI, rubidium. Rubidium has a fixed charge, comes in the first column. Therefore, we're going to use the monatomic rules. So rubidium. Iodide. '23 sulfur and fluorine. They're both nonmetals, so we will use the prefixes for the covalent rules. So there's only one sulfur, so sulfur. Hex, chloride.
Well, you had that wrong.
If you put hex, I'd give it to you.
Okay.
Because you're showing you know what you're doing, you just don't know whether to drop the A or keep the A.
In what circumstances will we drop the A?
It's pretty much when your vowels are back to back.
Well, I have a question. I don't know, like this was just like a mess up or whatever, but on, where'd it go? There was one on here and it had a double I. It's number 34 on the other one. It's triiodide.
Yeah, on that one you can't drop the
So it
you
was,
can't drop the I. You're
Okay.
stuck with it. From it, you can get from that you can tell. All right, number 24. 24 has a common name, but I don't want the common name. Okay, I really don't care if you've got the common name down or not. What I care is if you've got a set of rules. Nitrogen and hydrogen, 2 nonmetals. Name it based off prefixes. So nitrogen, trihydride. If you care about the common name, it's ammonia. All right, last one. N2O3. Nitrogen and oxygen, both are nonmetals. Therefore, since they are nonmetals, we will name with prefixes based off covalent bonds. So dinitrogen, trioxide. All right.
If we get that one, like number 24, and we put ammonia on there, it's going to be kind of wrong.
I give it to you. You're right.
Really?
Yeah. I can't count you wrong. Any questions?
what about if we do it, can we get bonus?
No. Any questions at all? I'll even answer questions from the second sheet.
How do you go backwards with the one? Like if you give us the Roman numerals.
Yeah, that's what I didn't know.
So
Like you give us the
Like,
so like 14.
Yeah.
Okay, this is the thing. Write down those ions. So like I did here, iron 3. So I wrote Fe3 plus. That's the charge of it. Nitride. I put nitrogen and a 3 minus because it comes from the 15th column. Now you got 2 different circumstances here. Is it a 1-to-1 ratio? In this case, it is a 1-to-1. because of 3 plus and 3 negative. It's the same number. Whenever you have that, you end up in the case to where it's a 1-to-1 ratio, so it's just iron and nitrogen next to each other. But in other... You got a certain one on there?
Number 10.
Okay, it's hard to see.
Or 9. Do 9.
It's hard to see, so I'll write it out from the side. Okay, so like on 9 here, it's iron 2, so I put Fe 2 plus. And then fluoride, which is F negative 1, because it comes from the 17th column.
So you got 2 from the numeral. The 2 positives. Like that.
Yeah, because the Roman numeral tells you the charge, not how many there is of them, it tells you the charge. So this 1 comes down here for the iron, which is why you see nothing there, because there's understood to be a 1. And this 2 comes over here for the fluoride, as you see here. Because when you look at it, those charges will cancel out now.
So you write them down and just like switch them?
Unless it's a 1-to-1.
Yeah.
But yes.
Okay.
Because that will work with the stock system, like here with the iron 2 fluoride, and it will also work with other ones like right here, for example, the barium nitride.
Is
Barium, the second column, so 2 plus, nitrogen's 15th column, so 3 negative, flip them.
So iron, number 14 with iron nitride, that just cancels out on it.
That's it. It's a 1-to-1.
Is it okay if we show our work on our test just as long as we circle our answer?
Yeah, that's fine. You can do this, so like what I did here, you can do this. But this is what I want.
Okay. So
That
it's
right there is
okay.
all I care
So
about.
we have to show our work.
You don't have to show
But
your
it's
work.
okay if we leave it.
Yeah, you don't have to erase it. Leave the work there.
How did you get the numbers? Separators on like lithium oxide? How did you get those numbers?
Lithium oxide. 16. Alright, lithium oxide. So when you're looking at it here, lithium, what's the charge on the lithium? Positive 1. How do I know that?
Well, it's a,
First column.
yeah, it's block.
Can't just say S block because
That's
if
why
you're in the first
I
column,
can't
it's,
think.
you're alright.
Slow down.
So it's a +1 charge because it's in the first column. Oxygen is where oxide comes from. Where's oxygen at? 16th column. It's 2 negative. So then you take these and just cross them over. That 2 goes down for the lithium, as you see there.
That's
And the
it.
1 comes down here for the oxygen. Can I stress something in here? Especially because I seen this yesterday when I was going around. These numbers are subscripts. That 2 is down here below the lithium. It's not up here like an exponent, like a superscript. If you write it as a superscript, you are wrong. If you're falling asleep right now in this class, you better shake yourself and wake yourself up. Because I'm telling you, when somebody looks at me and says, Mr. Hall, you didn't tell me this would be wrong. I'm literally recording this. It must be a subscript. And when they're subscripts, you don't show charge. I don't have a +2, a -2 down here. I don't have a -3 up here. It's just the number.
Do you have this on this worksheet?
Yes. It's processing right now. It will be sent out though. This one, the one from second period when we did this, the second sheet, and with you all, the one I just did for the first one, these both will be sent out to you guys today. So that you have it. Do not just get caught up on this though. Remember, you have stuff that you learned in this class before we did nomenclature.
So prefixes, we only usually 2 compounds, right?
Only covalent bonds, not metal and all metal.
Mr. Hall,
Yes.
let's say you put like carbon 2 on there, like C2, would that just be carbon, right?
Well, yeah, it's just gonna be carbon. What's it bonded with?
Just a C and a 2. It would just be carbon, right?
No, carbon is not a diatomic.
What are the 7 diatomics?
Seven diatomic. Here comes your seven diatomics. First one, hydrogen. Then from here, they make a 7 on the periodic table. You come here, you go nitrogen, oxygen, fluorine, chlorine, bromine, and iodine.
So if all of those are bonded, like that have a 2, it will just be the 9. You don't have to add.
Exactly.
Who said that?
So like, the monatomics and stuff, just kick off.
What is it?
Monatomics and stuff, is that what we're on before?
That was part of nomenclature.
So, metal bonds, metallic bonds.
Metallic bonds,
I just